Alright, how you guys doing today? Mr. Muscarella and my buddy Pythagoras still hanging with me here for this section 7.4 on special right triangles. Now there's going to be two videos for this section. First one is right now. We're going to deal with the first of these special right triangles. And they're called special because there are certain ratios that exist around them, and we are going to use those ratios to help us solve triangle problems, right triangle problems. So here we go. Let's get into our very first example of the 45, 45, 90 problem. But wait, there are formulas. For those of you guys who are formula people, you'll want to go ahead and make sure that you memorize those two pieces on the left, where it says the hypotenuse equals the leg times square root of 2, or the leg equals the hypotenuse times square root of 2 over 2. Those will be two formulas that will get you through these. For other people who are more visual, you'll want to take a look at that picture and memorize that ratio of 1 to 1 to square root of 2. Now some textbooks will actually rewrite this as this. They'll have your triangle, your right triangle, and instead of a 1, 1 root 2, they'll put it as x, x, and then x square root of 2. They'll write it like that sometimes. So either way, just know they're in a 1 to 1 to square root of 2 ratio for the two legs and the hypotenuse. So that is what the 45-45 triangle theorem is. Now let's actually get into playing with this. Now, if you want to go ahead and take a look at some very quick, easy videos on how to do this one, be sure to check out how to solve the 45-45-90 given one leg video. And that's just an intro video. Now for this piece, here we go. Find the length of the hypotenuse. So we've got to find the length of the hypotenuse. So first thing we got to do is identify where the hypotenuse is. Bam! Right here across from the 90-degree angle. So there's my hypotenuse. Now to find that, there's a couple ways we can do this. We're going to use the 45-45-90 triangle theorem piece first, and I know that this leg and this leg are both going to be the same, so that leg is 8. Now the hypotenuse is square root of 2 times as long as the leg, which means your hypotenuse is going to be 8 square roots of 2. That's it, man. That's pretty easy, right? Now here's one way you can verify this. This, we're going to use my old buddy Pythagoras here, one of the theorems that was named after him, which he actually got from somewhere else, but that's another lecture. So the Pythagorean Theorem you could use to double check this as well. So if you're going to use Pythagorean Theorem, you're going to have 8 squared plus 8 squared. Those are going to be my two legs. And then the hypotenuse, I don't know what that is. So I'm just going to call that h for hypotenuse. So h squared equals 8 squared plus 8 squared. Well, 8 squared I know is 64 plus another 64. All right, so that's going to be h squared. Now, if I find their sum, I get 128. And then h is going to be, the hypotenuse is going to be the positive square root of 128. Remember, in algebra, you'll want to deal with the positive and negative, plus or minus the square root of 28, but in geometry, we're dealing with distances and lengths, so we only worry about the positive one. Now, square root of 128, when you simplify that, that's going to simplify down. And I'm just going to kind of go across right here. You're going to have the square root of 64 and the square root of 2. So when you simplify the square root of 64, you get 8. And then square root of 2 can't do anything with it, so boom, you're done. So you could use Pythagorean Theorem, help you verify that as well. Now check out number 2 here. This guy's a little bit different here because we have both legs already. Now how do we know that's 45-45-90 triangle? Boom. This guy and this guy are both the same. So that means those two sides are the same. And if you remember from earlier in your geometry days, if two sides are the same in a triangle, then the angles opposite are the same. All right, so how do I know they're both 45 and not like both 30? Well, I'm glad you asked. That is because right here we've got a 90-degree angle, which means the other two angles have to have a sum of 90. So if they have to have a sum of 90 and they're both the same, that means each one of these angles would be 45 degrees. Booyah! So sometimes you'll get a picture where they'll tell you that the angle is 45 degrees, like in example 1, and other times you'll have to pick that apart from the diagram and see that both legs are marked the same, like in example 2. So let's go ahead and get after this one. Now again, the hypotenuse is square root of 2 times as long as the leg. So if my leg is 3 roots of 2, so square root of 2 times 3 square roots of 2, well, the square root of 2 times the square root of 2, and I'm going to do this a long way first, would give me the square root of 4. But I know that the square root of 4 is 2, so that's like 3 times 2 then, and we all know that 3 times 2 is 6. So booyah, the hypotenuse has a length of 6. So that's all there is to finding the length of the hypotenuse when we have the leg. Alright, and I want you to keep your work nice and neat and organized just like that. Now, if you want to do that using Pythagorean Theorem to verify, check it. Now, using the Pythagorean Theorem, we could have done the same thing. You could have h squared equals, and then each leg squared, and then added together. That's that first line. And then when you take 3 times the square root of 2, square that. Remember that, how I showed you guys to do that? If not, remember, there's over in the skills drill playlist, it'll take you through how to do that, because 3 squared is 9, times it by the number underneath the square root. Boom, 18, you're done. Bam. So you got h squared equals 18 plus 18. 18, that's easy, that's 36. When you take the positive square root of 36, booyah, you end up with 6. So now here for examples 3 and 4, we've got to find the lengths of the legs in the triangle, which means bam bam, we've got the hypotenuse. Now if you're the formula person, you can kind of think about it like this. The leg equals the hypotenuse times square root of 2 over 2. So from a formula people, you'll kind of take a look at it like that. Now the hypotenuse, I can see up there in the picture, that's 5 square roots of 2. X equals, the hypotenuse was 5 square roots of 2 times square root of 2. All of that over 2. And we already know that square root of 2 times square root of 2, that's just going to give us 2. So I'm going to have x equals 5 times 2 over 2. Now it depends kind of how you want to simplify that. Some people just be like, oh, let me just cancel out the 2's and check it. You do that, boom, boom, you end up with 5. If you didn't want to cancel the 2's out, you could have said, well, in the numerator, 5 times 2, you would get 10, and in the denominator, you get 2. So when you divide that out, boom, same thing. You still end up with 5. So that's one technique right there. Now I'm going to do the other way. I'm going to abbreviate this PT, because you could use a Pythagorean Theorem to do this as well. So if you want to use Pythagorean Theorem, check it out, man. That's all you got to do. You could have 5 square root of 2 squared, set that equal to, this time both of our legs are the same, so we got x squared plus x squared. Well, 5 square root of 2 squared, when I square that whole thing, I end up with 50. And then x squared plus x squared, I get 2 of my x squareds. Now, I've got to divide both sides by 2 to get rid of the 2 in front of the x squared. So when you do that, you get 25 for your x squared. And then when you square root 25, and again, keep your work nice, neat, organized, taking the positive square root of 25, you get 5 for the value of x. So either way you do that Pythagorean Theorem or 45-45-90 Theorem, bang, you got this stuff. Pretty easy. Go ahead and try example 4 on your own and do this problem both ways using the theorem as well as using Pythagorean Theorem. So go ahead and hit pause, try number 4 on your own, and then come on back and see how you did. Alright, Rockstar, how'd you do? Did you get that one right? Yeah, I figured you would. Now, make sure that you show your work, you keep it nice, you keep it neat, you keep it organized, because that's really going to help build your understanding of mathematics and help you also pick up some patterns and things as you go through your math careers. So that's it on this part. This is going to be part 1 of the special right triangles, the 30, the 60, the 90 triangle. That's coming up next in a separate video. So that's it for this one. Make sure you watch the next one. Peace out for now.